So to start, we're going to set a timeout, which is going to accept as the first argument a function that's just going to console log timeout. Second argument is going to be the number of milliseconds. We run that, it'll wait 1 second, 1,000 milliseconds, and echo out timeout. If we change it to 5,000, it'll wait 5 seconds or 5,000 milliseconds and then log out timeout. Now we're going to change this to interval and use setInterval, and what that's going to do, unlike timeout, instead of waiting and then running once, it'll run every that amount of time, or every 1 second. So here we see interval every second, and then after 5 seconds timeout. Next I'm going to create a constant, myInterval equals setInterval, and then after 5 seconds the timeout is going to clear interval, passing in that interval to stop the interval. So what we'll see is interval every second. After 5 seconds, the interval will stop and the program will terminate. Next, we're going to set a timeout for 5 seconds. And when that timeout runs, it's going to console log first timeout. Then it will start a second timeout. And when that timeout runs, it'll start a third timeout. So as you see, we nest 3 timeouts inside of each other and log first timeout. Then we're going to log second timeout and third timeout. Each timeout is going to wait 5,000 or let's say 1,000 milliseconds or 1 second, and in the console we'll see first timeout, second timeout, third timeout, and the program ends. This obviously isn't ideal because of the nesting that's involved. Let's flatten this out, and what's going to happen here is instead of running the first timeout, then running the second timeout, then running the third timeout, it's going to start all 3 timeouts concurrently, and after 1 second each timeout will complete all concurrently or at the same time. To illustrate this better, we'll stagger them. So after 1 second, 1.5 seconds, and 2 seconds. So we'll see first, second, and third timeout in the console. What if we wanted to wait until all of these are done and then do something? Well, we'd have to set some sort of counter and increment it each time a timeout completes. So let's demonstrate that here. We'll do counter ++ and log out the counter in the console.log. Counter ++ log out the console log. Let's just move this up here. And what we'll see is the value of the counter increases. And we know that there's 3 timeouts. So as each timeout completes, we would have to check this counter and see if it's equal to the number of timeouts that are there. And just to make this more interesting, we'll kind of randomize these timeouts. So it could take anywhere up to 1 second or 2 seconds. Let's see that it's not math.rand, it's math.random. Let's fix that right here. And what we'll see is the 3 timeouts kind of randomly run. And then we want to actually do something after all of them complete. So we'll create a function here, check if done, and then we'll call that each time a timeout completes. Now this function isn't implemented yet, so let's go ahead and implement that here. And we'll actually move that up to the top here so we're not relying on hoisting. And what we'll do is we'll check if the counter is equal to 3, which means we're done, in which case we'll log out, you are done. Let's go ahead and run that, and you see second timeout, first timeout, third timeout, you are done. And if we keep running that, we'll see the timeouts complete randomly, and then we see you are done only after they're all done. Now this isn't ideal because we have to manually create this counter and increment it. And as you saw before, when we want to do something and then do something else, we nest it. So introducing promises. Promises are a better alternative. It represents an eventual value. So here's a promise, and it accepts a callback. So a promise is implemented using callbacks. And then we're going to set timeout and call the resolve function after a random amount of time, meaning that this promise will resolve after randomly up to 1 second. And then, or let's change that to 2.5 seconds here. And so we're going to copy paste this and call this first promise, second promise, and third promise. And down here we can actually do something with these promises. So we'll say first promise dot then, which means when the first promise completes, then we're going to do something. And this accepts a callback. In this case, we'll just console.log first promise. And then with the second and third promises, we'll log out second and third promise. And it looks like I've got a bug here. I forgot to rename the first variable there, second promise and third promise. So I quickly just pause and fix that bug there. And so after that's renamed to first promise, second promise, and third promise, it should behave correctly. And to kind of see this better, let's have each one wait for a random amount of time up to 5 seconds and run that. And we see third promise, second promise, first promise. We run it again, first promise, second promise, third promise. And it should be more or less random each time. We can speed that up here by changing it to 1,000 milliseconds. And you'll see it does the same thing essentially, but runs faster. So let's go ahead and now illustrate chaining. So instead of running the promises concurrently, what if we want to run one promise after another? Well, we can actually return a promise from the .then block. What that's going to do is when the first promise runs, then it'll run this callback that logs first promise completed and returns a new promise. And then when that promise runs, it'll basically trigger the next .then block on line 16 down there, and it'll run the callback second promise completed. So let's clean this up here a little bit, and we'll go ahead and start a third promise inside of the second callback and return that promise in there, and then tack on a .then at the end, and then we'll go ahead and console.log third promise completed. And if we run this, looks like we got a bug in here. Forgot to define first promise. So I'll just define that up here really quickly. And if we run that, we see first promise, second promise, third promise, and it always completes in order. So even though they're randomized, it doesn't begin the second promise until the first one completes because we've chained the .then. So we can clean this up a little bit. Instead of copy pasting these promise constructors, we can create a function here called createRandomPromise. And what that'll do is return a promise that waits up to 1 second randomly and then resolves or completes. And so inside of here, instead of creating a new promise, we can call createRandomPromise, and it'll behave exactly the same. So we can even shorten this up, and we can just do .then and pass a reference to the function instead of invoking it, and just make the code a little bit more terse. So if all that you're doing in the .then is beginning another promise, you can kind of do it like this and chain it, and it gives you a nice readable syntax. So let's go ahead and add a console.log in here so we can see what that's doing, and we'll see a promise completed, a promise completed, a promise completed. And we could tack on more .then calls. We'll go ahead and put a number variable here and increment that. And we can see a promise completed 1, 2, 3, 4, 5. We can continue chaining these on as much as you'd like, and they'll just kind of chain one after the other. We can speed that up, and we can slow that down. So here it'll wait up to 10 seconds or 10,000 milliseconds. And then it'll go on to the next promise. So you see in the console a promise completed, etc. I'll go ahead and let that run here for a second. So another concept is resolving to a value. Normally you're doing like an API call and you're getting back a result, and the promise will resolve to that result. And you can capture that value in the .then block. Here we're going to resolve to math.random, and in the .then, we're going to head and capture that. So we're going to do console.log value and pass in the value as the first argument to the then callback. And we'll just say resolved with value. And we see in the console there, resolved with 0.97 or 0.31. It's random every time. So your promise can return some data asynchronously. What's this mean? Well, maybe you're loading some data off disk or doing a network call, and after some amount of time, that is going to complete and the .then will run. Likewise, if that fails, the promise can reject with something like a value or an error message. Here we see unhandled promise rejection because we're not handling it, so let's go ahead and handle it. We're just going to catch, and that's going to accept an error, and we're going to console.error or log out that error. So it's just like the .then, but instead of when it runs on resolution, it'll run on rejection, and you'll catch the error and handle it maybe by retrying it or crashing, exiting the program. So there, as that one rejects, we hit the .catch block and it does console.error, and we see the value that it rejected with. Normally that'd be a useful error message about what went wrong. Here we're just rejecting with math.random just to demonstrate the concept of promises. So we can separate this out, and we'll call this create random promise that fails, and this one's going to reject after about 1 second, and create random promise is going to resolve. So one succeeds and the other fails. It's going to resolve or reject with a random number. We could just pass an underscore there since we're not using the resolve, but I'll just leave it as resolve. So if we do create random promise and then put a dot then, and I'll kind of break this out longhand here so we can see the difference. We're going to say resolved with value, and in the catch block we're going to say console.error rejected with value, and in the console there we see resolved with some random number. If we call promise that fails, we'll see rejected with some random value. And it skipped the dot then block because when it rejects, it jumps to the next catch. We'll see this in the next example. So I can break this out long form here and say first promise got resolved, and then return another random promise from the then block, and then log out second promise got resolved, and then here I'm going to return a random promise that fails. So this third promise fails, and then it'll hit the catch block and say rejected. So you see first promise, second promise resolved, and then rejected for the third promise down there in the console. If the first one fails, it'll skip the second promise. It'll skip this then block and go straight to the catch. As soon as anything fails in a dot then chain, it'll jump to the next catch. So this one right here is skipped. And we can kind of demonstrate that, and we'll have 3 dot then chains here. And so, let's see, they all return a failing promise. So the first promise resolved and returned a failing promise, and it jumped to dot catch. If the first one returned a promise that resolves, then the second promise will run, which then rejects, and we short circuit the third one and hit the reject block. So you can kind of see how this works here. If we put a dot catch block, we catch the error, and then the next dot then does run because the error was handled. So it'll jump to the next catch block, it'll short circuit any dot thens and go to the next catch here, and then that'll consider the error handled, which allows the next dot then to run, because catch returns a promise that resolves, which then triggers the next dot then. So we see first promise got resolved, rejected as we handle it, second promise got resolved, that returns a rejected promise, third promise gets skipped, and we hit the last catch. Here I'm going to create 2 named promises, promise A and promise B, by calling my create random promise, and I'm going to race them. So I pass in the array of promise A and promise B. We don't know which one's going to complete. It's a race. Complete first, rather. They're both completing, but one will complete before the other because they're random. So it's a race. And in here, to make this easier to understand, I'll resolve with the value instead of a random number, and it'll then log in the console A or B so we can see what exactly is happening instead of just a random number. So these promises are going to race, then the value we're going to capture is going to get logged, and here you see which one completed first was B, then we run it again, it was A, erase it again, it's B. You can keep racing it over and over. And then .all is going to wait until they all run and then complete.